All right, we're done with Unit 9. We're ready to take the practice test. Make sure we're all set for the test. So let's get going on this. Usual instructions there. Let's make sure we circle our answers. It starts off and it says find the slope of each line, then state whether the lines are parallel, perpendicular, or neither. So I'm going to slide down here just a tad. You'll notice that we've got equations for each one of these. We've got a pair of equations here, places to put the slope for each one of them, and then all we have to do is just circle whether they're parallel, perpendicular, or neither. Now remember, we've got to put this in slope-intercept form in order to see what the slope is. So to do that, I'm going to go ahead and I'm going to move the 5x to the other side. I'm going to do that by subtracting. So we get negative 2y equals negative 5x and then minus 4. And we need to get rid of that negative 2, so we're going to divide everything by negative 2. And just a quick reminder here, we really don't care what the y-intercept is. All we care about is what the slope is. So this is going to be 5/2 x. So we're going to say the slope is 5/2. Now once we've got that identified, we're going to come down here and take a look at this other one. Again, we're going to move that to the other side by subtracting. So we're going to subtract 3x. So we get negative 4y equals negative 3x minus 7. Again, we really wouldn't have to write that one down. We're going to divide everything by negative 4. So we get y equals, this would be 3/4 x, and we can stop right there. That is 3/4. Now, if this slope is 5/2 and this one is 3/4, they're not the same and they're not opposite reciprocals. So that means this one right here is going to be neither. Let's take a look at the next one. Again, moving that 2x to the other side. So I've got a 4y, I've got a negative 2x. I'm not even going to bother writing that negative 5. We're just going to divide by 4. So we get y is equal to negative 1/2 x. So we've got negative 1/2 right here. And then we'll take a look at this guy. We move the 2 to the other side, so this is going to be a negative y. This is going to be a negative 2x. I'll go ahead and write that 10 right there just for the heck of it. And then we're going to divide everything by a negative 1. So what we're after here is y equals 2x. So the slope on this one is 2. Now, they're not the same, so there's no way it can be parallel, but these are opposite signs and they're reciprocals of each other. So that one right there is perpendicular. So we'll go ahead and circle that one. We'll take a look at this one, very similar to that last one right there. Let's take a look. We're going to do this by subtracting 2x. So we get y equals negative 2x. Gosh, we can stop right there. Slope on this one is negative 2. We're going to take this one, move the 6x over, so we get 3y equals negative 6x minus 1. We're going to divide by 3. I'll go ahead and write it on all of these. So we get negative 2x. Stop right there. Slope is negative 2 on both of these. That's going to make it parallel. So let's make sure we're getting those right. Those are pretty simple problems. Let's come down and take a look at the next one. So we've got these pairs of points. So we want to find the slope between these 2 points, the slope between these 2 points, and then make a decision about whether they're parallel, perpendicular, or neither. So on every one of these, we're going to use that formula m equals y2 minus y1 over x2 minus x1. So what I like to do to make sure I don't make any mistakes is I like drawing these lines right here. So there's y2 minus y1. So this is going to be 1, write the minus, and then go grab the number right there. So that's a negative 2. And then we're going to do x2 minus x1. So this is going to be 9. Again, write the minus because it's part of the formula. Then go grab that point. It's a common thing for people to look at that and say, oh, there's already a negative there, so I don't need to write one. Remember that minus or negative times a negative, minus times a negative, however you want to think of it, that's going to turn into a plus. So that's going to be a 3 on the top. That's going to turn into a plus, so that's going to be a 12 on the bottom. Then we're going to simplify that, so that's going to end up being 1/4. So we get a fraction 1/4 for the slope right there. And then on this one, we do the same thing. Again, I'm not going to write the formula. I'm just going to go ahead and do y2 minus y1 over x2 minus x1. So this is going to be negative 2. Write the minus, then grab that y value. Again, don't mix these up. So then we're going to do 5 minus. So this is x2 minus x1. That's a 3. So on the top, we get a negative, let's see what we've got here, negative 8. And on the bottom, we have a 2. So we end up with a negative 4. So the slope on this one's a negative 4. They're opposites and they're reciprocals. So this one is perpendicular. We'll go ahead and do this one. So this is going to be 3 minus 0. And then this is going to be 0, careful here, minus that minus 4. So this is going to be a 3 on the top and a positive 4 on the bottom. So careful with that. So that's 3/4. And then again, y2 minus y1 over x2 minus x1. So 6 minus 3 and 8 minus 4. So this is going to be a plus, and that's going to be a plus. We get 9 on the top, we get 12 on the bottom, and lo and behold, that's going to go ahead and simplify to 3/4. So because they're both exactly the same, those are parallel. Let's not jump to any conclusions as to what the answer is because we've got to show our work on this. So we're going to do 0 minus minus 4 and 10 minus 5. So y2 minus whatever y1 is, and x2 minus whatever x1 is. That's going to be a plus 4 here. That's going to be a 5 right there. So this is 4/5 on that one. And then we'll take a look down here. This is y2 minus y1, so 13 minus a minus 8, and then 5 minus a 9. So let's see, if we put the two of those together, we're going to end up with, let's see, that's a 21, because that would add together. And this is going to be a negative 4, so we get negative 21/4. Not even close to the same, so that's going to be a neither. And then we'll go ahead and take a look at the next page. Okay, on page 2 it says, write an equation in slope-intercept form for each line according to the given information. So slope-intercept form, remember, we need to write this as y equals mx plus b. They've asked us to write it in that format. There are a couple of others. I'll show you one here in just a second. So this one has to go through this point right here. So it's got to contain that point, and it's got to be parallel to y equals 3x plus 2. So the slope on this line right here is 3, and if we want it to be parallel, our slope has to be exactly the same. So our slope has to be 3 as well. Now, I like to write theirs and ours here. You don't have to do that. We want to use this slope right here. So one way to do this problem is to just say, well, this is y equals mx plus b, so I'm going to write y equals, I need 3x plus b, so we're nearly done with this one. All we need to do is we just need to find the y-intercept. Now, it's got to go through this point right here, so if this is an x value and that's a y value, I'm going to put this y right here, and I'm going to put this x right here. Common mistake is to just put the 3 right here and then the 4 right here. Put them in order. It doesn't work that way. We want to put the y over here, so we're going to put 4 equals. This is going to be 3 times the x value, which is 3, and then we're going to add b. So this is 4 equals 9 plus b. We're going to subtract 9 from both sides, and we get b equals negative 5. So then we come back up here and we say, look, we were almost done with this. Now I just need to put this in right here. So we get y equals 3x minus 5. And that is the answer. Now, sometimes I'll put a dotted circle around this one just so we can keep track of it a little bit better. We're mostly done with the problem right here. All we need is this guy right here. We plug it in, and then we're all set to go. Now, we're going to take a look at the next one here. This one says we want it to go through the point negative 2 comma negative 5, and it's got to be perpendicular to that line right there. Well, you'll notice again, this is already in slope-intercept form, so this means their slope is 2/3. If we want ours to be perpendicular to theirs, then it needs to be the opposite reciprocal. So that's going to be opposite is going to be positive, and then the reciprocal is going to be 3/2. So we're going to do 3/2 here. So I'm going to do this one using not slope-intercept, but I'm going to use point-slope form. So point-slope form, remember, is y minus y1 equals m and then x minus x1. Now, you can do the same technique here. I'm just going to show you on 1 or 2 of these that you can use both of these methods. So the cool thing about this is x1 and this is y1, and we've got our slope right here. I'm going to put a dotted circle around that so we don't lose track here. So here's what we're going to do. We're going to do y minus whatever y1 is, so that's a minus 5. And then the slope, which is right here, so that's 3/2, and then x minus whatever x1 is, so that's going to be a minus 2. Now, the cool thing about doing it this way is it generally takes a little bit less work. Slightly more straightforward here because all we have to do is just simplify this. This really is a perfectly good equation. We just need to simplify it a little bit. So I'm going to write this as a plus, and I'm going to write that as a plus. So we get y plus 5 equals, and then I'm just going to distribute this through. Well, this is going to be 3/2 x, and then if I multiply 3/2 times 2, 3/2 times 2, remember this is 2/1, those are going to cancel, so this is just going to be a plus 3. So all we need to do with this is just move the 5 over to the other side. Those are going to cancel. We get y equals 3/2 x, and then this is going to be minus 2. That right there is the answer. A little bit quicker in my opinion, but again, you can do it with either method. So I'm going to come down here, and I'm going to do number 9 using the point-slope formula. We're still going to change it into slope-intercept, and then I'll come back here and I'll do number 10 just using slope-intercept exclusively. So when we look at number 9, we'll notice that we've got this point right here, and we've got to make a line that's parallel to this one. So we need to figure out what the slope is, and it's not in slope-intercept form. So just like we did on the other page, I'm going to go ahead and move the 2x to the other side. So we're going to have 5y equals negative 2x and then plus 25. If we wanted to go through and divide everything by 5, that would be fine, but what we really care about is this negative 2/5 in front there. So what this means is their slope is negative 2/5, and if we want ours to be parallel, it's also got to be exactly the same. It's got to be this right here. Now, if you want to go ahead and put a circle around that, that's totally okay. It doesn't make any difference. It's not as big a deal on parallel ones as it is on perpendicular ones, because they do have to switch. So we're going to do this one again using point slope form. So I'm going to do y minus y1 equals m and then x minus x1. So the y is right here, so this is going to be y minus a minus 3. The slope is negative 2/5, and then we're going to have x minus whatever that x value is, so that's a 5. And then all we do is we simplify, so this is going to be y plus 3. When we distribute through here, we get negative 2/5 x. And take a look at what happens here. We have a negative times a negative, so that's going to be a positive. And then the 5s will cancel, so that will just leave a 2 right there. And then the only thing left to do is to move that 3 over, so we go ahead and do that. And we get y equals negative 2/5 x minus 1. Whoops, 2 minus 3 is 1. And we'll circle that and we're done. Now I am going to go back to slope-intercept form for this one right here, but we've got to make sure that our line is perpendicular to this one right here. So this line, now remember, we've got to have it in slope-intercept form, so think about this for a second. There is no x value here. There's no x, so that means it must have been a 0. So remember, if you've got y equals negative 2, you've got a horizontal line. So what this means is we've got a vertical line. So remember, if this has a slope of 0, kind of the reciprocal of that would be, I mean, it's so steep there's not even a number that represents that, kind of like if you did 1 over 0 if you did the reciprocal. But anyway, so we've got to have an x equals a number. So this is going to be x equals which number right here? It's going to be x equals negative 5. So that's it right there. So if you have y equals negative 2 and you want a line to be perpendicular to that, well, we'd have a line over here at, okay, perpendicular line right there, x equals negative 5, and it would go through negative 5 comma 1. So we should be in good shape there. Again, that's a nice quick one there. Let's go ahead and take a look at this. It says find the distance between the 2 points. Right answer is in exact form and rounded to the nearest hundredth, so we better have a calculator ready to go on this. So remember, the distance formula is this. So I'm just going to go ahead and write it down. It would be good if you wrote it down. D equals, we've got a big square root, and then it's x2 minus x1. Remember, on the slope formula, the y's go on top, so we kind of do those first, and then the x's on the bottom. This is different. We're going to do the difference in the x's, and then we're going to square that plus y2 minus y1 quantity squared. So again, this is x1, y1. This is x2, y2. And again, common mistake for people to make is they put them in the wrong place, they mix them up and different things like that, and they don't keep track of the minuses and the negatives and stuff. So here's what we're going to do on this one. I'm going to go ahead and do the x2 minus the x1. So on this one, we're going to have d equals big square root. x2 is negative 3 minus x1 is 5, quantity squared. And then we're going to have y2, which is the negative 3, minus the 1 right there, okay? Now, sometimes I'll drop that square root here, so I'm going to do a negative 8, and I square that. This is a negative 4, and we square that. So when we put these together, we get a 64. So when you square that, you get 64. Square this, we get 16, and then we get an 80 put together right there. Now, I am going to bring back that square root because the answer is the square root of 80, but we want to make sure that it's simplified, and we want to write the answer as a approximate decimal here. So let's keep in mind that this right here is, this is 5 times, let's do 10 times 8. So we'll do 8 times 10. This is a 2 and a 5. And this is a 4 and a 2 and a 2 and a 2. Now, if you're quicker at doing that and you can recognize that this is actually 16 times 5, that would be okay. But we've got a 2 times a 2 times a 2 times a 2 times a 5. So we've got a pair of 2's here, and we've got a pair of 2's here. So 2 2's on the outside, that would make this a 4, and we've got a square root of 5 right here. So we think that's the answer, but let's go ahead and pull up a calculator here. And let's just double check and make sure. So I'm going to go back to the home screen, clear everything off, and I'm going to type in a couple of things. I'm going to do the square root of 80 first and just see what we get. So we get 8.94, and then I'm also going to type in 4 and then square root of 5, because what this is going to do is it's going to make sure that we got the right answer and that we simplified the right way. So we get 8.94. Now, we want to say this is approximately equal to, so let's see. This is either, if we're going to go to the nearest hundredths place, so that's 2 decimal places, this is either going to be 94 or 95, and that 4 right here is not enough to bump that up. So this is going to be 8.94. So there are our 2 answers. There's our exact answer with the fraction, or with the radical, and then there's our approximate answer right here. So let's go ahead and do this one. We'll see if we can speed this up just a little bit. So we're going to do a big square root, and we're going to do x2 minus x1, quantity squared. We're going to do y2 minus y1, quantity squared. And again, if you wanted to write these arrows right here, so you made sure you kept them straight, that would be great. So I'm going to put a plus right here. So this is going to be 9 squared. This is going to be, let's see, we've got a 3 squared here. And again, there's not an absolute need for parentheses on there, but it's not a bad idea if you do. So this is going to be 81 plus, let's see, if we, not 3 squared, that's going to be 9, so we get 90 right here. So this is the square root of 90. We want to simplify that. We'll notice that this is a 9 times a 10, which of course is a 3 and a 3. So what we think the answer here is 3 radical 10. So we'll go ahead and circle that, and then we'll throw it in the calculator. So again, we're going to check and make sure. So we're going to do the square root of 90. We're going to type in 3 square root of 10. And that means we simplified it correctly, and we've got, so this is either going to be a 48 or a 49. That's enough to bump that up. So this is going to be approximately 9.49. So we've got our 2 answers, the exact one and the decimal approximation. And then we'll do this guy right here. So again, we're going to do x2 minus x1. So we do these guys right here. And then we're going to square that, and then we're going to do y2 minus y1. So this is going to be 9 minus 5 quantity squared. So this is going to be, let's see, 7 minus 3 is 4, 4 squared. This one on this, 9 minus 5, that's a 4, so we square that. 16 plus 16, so we get the square root of 32. So our answer on this one's the square root of 32. Let's go ahead and simplify that. Quickest way to do this is if you recognize that this is 16 times 2, we got a pair of 4s right here. So there's our pair that we can take out. So this is going to be 4 radical 2. Again, we think that's the right answer. Let's double check on the calculator. So we're going to hit second square root 32, 5.656. And then we're going to do 4 square root 2. Doesn't take very long to do that. And we double check, we make sure we get the right answer. A couple of extra seconds making sure that those match up. So we get 5.65 or 66. That 6 is going to bump it up. So this is going to be 5.66. So there's our answer right there.